Hi everyone, welcome to Tuesday, our third week of summer learning. I'm going to change this right here for Tuesday. I'm going to show you problems 1 through 5. Feel free to try them first and then look here, or if you need to, look here first. The first one is 863 divided by 7. These are always a little bit strange. I'm gonna actually fold this over and do this on this side. Because when it looks like this, it actually kind of seems like the reverse. You're actually putting 863 divided by 7. So that's the way you set these up. So even though it looks like it might be the opposite, you kind of flip-flop them. But if you just remember the way you read it, 863 divided by 7 or 863 divided by 7. All right, I'm gonna do it both ways. I'm gonna do the divide, multiply, subtract, bring down, my method, or the standard algorithm. I'm gonna write my multiples: 7, 14, 21, 28, 7 times 1 times 2 times 3 times 4 times 5 is 35. 6 is 42, and 56. I'm going to stop there. Remember, you can always do this. 1, 2, 3, 4, 5, 6, 7. 7, 8, 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19, 20, 21, depending on, and you might know your multiplication facts and not need to do this at all. So I'm gonna look at my first digit here, 8. 8 divided by 7. Will 7 fit into 8? Or 8, if I have 8 pencils, can I divide them with my 7 friends? And how many would each get? 7 here would be 1 time. Divide, I just did. Next I'm gonna multiply. I just wrote down the 1. 1 times 7 is 7. Next, I'm going to subtract 1. Next, I'm going to bring down the next digit, which is 16. 16 divided by 7, or if I had 16 pencils and divided them between 7 of my friends, how many would each get? 14 is my closest number to 16 without going over. How many times will 7 fit into 16? 1, 2. And then I'm going to multiply. 2 times 7 is 14. Then I'm going to subtract. Then I'm going to bring down my 3. Then I'm going to do it all over again. If I have 23, 23 divided by 7, or sometimes you can think about it, 7 times what number is closest to 23, or you have your multiples. There's lots of options here. 21, 1, 2, 3, 7 will go into 23. 7 will go into 23 3 times. 3 times 7 is 21. Then I'm going to subtract, and then I have a 2. That's my remainder, okay? Now, the big 7 way is still 863 divided by 7. All right, how many, can I get any hundreds in there? Yeah, I can get 100, right? So I'm going to put 100 here. How many hundreds? How many hundreds? 7 times 100 is 700. Still going to subtract just like over here. Okay, now no more hundreds will fit. How many tens will fit? Well, 7 tens is going to be too many. And we can do it, I'm sorry, I think y'all also do it like where you do 1 10 at a time. So let's do that. Let's do 1 10 at a time, because will 1 10 fit? No, 1 10 will not fit. See, this is where I get a little bit confused because I don't usually use the big 7. All right, let me see here. 10 times that's 70. Oh, I know what my problem is. I didn't bring down this 1. That's what happened. I couldn't figure out why it was happening. So here when I subtracted, I got 3, 6. I forgot to subtract my my hundreds. So how many times will 7, how many 10s will fit into, how many 70s will fit into 163. This is where if you wanted to do it one at a time, I'm going to show you that way. And if I'm confusing you, then don't listen to my Big 7. I'll put a video on Big 7 up there so they can probably explain it better. 3, make this 16, 9. I don't usually use Big 7 in 5th grade, so that's why I'm kind of out of practice. I can do another 70 out of there. I can't do any more 70s. How many 7s will that be? I'm going to put 3, would be 21, and 2. And then I would add this up, 100, 110, 120, 123, remainder 2. Okay? Like I said, I'm going to put a video on Big 7 because I know a lot of 4th graders use this, and then we usually transfer into the algorithm in 5th grade, but obviously y'all aren't there yet, so I will do a video on this so y'all can kind of get straighter on Big 7 if that's your method that you prefer. All right, so my answer is 123, remainder 2, 123, remainder 2. All right, number 2, what is the product of 27 and 26? What does product mean? Well, it's the answer to a multiplication. So we have 27 times 46. The standard algorithm way, 6 times 7 is 42. Carry my 4. 6 times 2 is 12. Plus 4 is 16. Finished with this. I'm going to put my 0 down because now we're multiplying by 40. Do my 1s first. 4 times 7 is 28. Carry my 2, but it's a plus. 2 times 4 is 8, 9, 10. And then I add those together. 6, 14, 2, and 1. The box method is we have 20 plus 7, 40 plus 6. I'm just writing those in expanded form. 2 times 4 is 8. Add my 2 zeros. 20 times 40 is 800. 4 times 7 is 28. 0. 2 times 6 is 12. Plus 1 0. 6 times 7 is 42. And if I add these all together, I'm going to add them up here. I'm going to do them all straight down since I'm going up here. 280. Let me move it over here. 120 and 42. So 2, 8, 9, 10, 14, carry 1, 8, 9, 10, 11, 12, 1,242. Okay? Either way is fine. All right, number 3. Julie had 2 blue ribbons, 1 green ribbon, and 3 red ribbons. If she randomly picked 1 ribbon, what letter on the number line would represent the probability that she would pick a blue ribbon? So we're dealing with probability, which we have not talked about so far. So with probability, we need to figure out what is our total number of ribbons. So we have 2 ribbons plus 1 ribbon plus 3 ribbons. So 2, 3, 6 ribbons would be our total. And if you wanted to draw a picture, you could have, here's my blue ribbon, green ribbon, and then I've got 3 red ribbons. So that's where I'm getting this. So if this were in a bag, let me see if I can draw a bag real quick. All right, not a very good bag, but if you're putting your hand in here, how many choices would you have? 1, 2, 3, 4, 5, 6. And they want to know what's the probability that she'd pick a blue one. Well, how many total blue ones do we have in here? 1, 2. So 2 out of 6 turns, okay? So if we look at our number line down here, we've divided it into 6 because this is 1, 2, 3, 4, 5, 6. So where is 2, 6 on the number line? 1, 2, right here. So our answer would be B. And that also comes into fractions. You can know that half of 6 would be 3/6. So we know it has to be less than a half. okay? Number 4, Joe ate 1/8 of a cake. Sue ate 3/5 of a cake. How much cake did they eat all together? So I've got Joe ate 1/8 of a cake. Sue ate 3/5 of a cake. How many did they eat all together? So all together, I'm going to add these together. And I showed you an example of this on the last DMR. Remember, you can use your manipulatives to help you, because what this is saying is we've got how many fifths? We've got 3/5. 1, 2, 3/5 and 1/8. So if I wanted to add these together, they're different sizes, so I don't know how many total they are together. I'm going to do this on the other side too. 1/8 and 3/5. So here's my 1/8 and my 3/5. So I need to turn them into the same size pieces. So I need to find a common denominator. So that's where I do my M, my least common multiple. That's where we get the M from. Put my denominators here. 8, 16, 24. Oh, we got to go far this time. Times 2 times 3 times 4. 32. And times 5 is 40. 5, 10, 15, 20, 25, 30, 35, 40. All right, this one is kind of a big one to jump. Unfortunately, I don't have pieces that are 40s, but if I did, let's just see if I could do that. And let's try to make this. If I divide this in half, so this will be 8. And actually, I'm going to make it into 15 fives. Sorry. Just to show you the other way. Trying to show you in this. I'm sorry. Okay, let's see here. 1, 2, 3. All right, that's pretty close. All right, so that's fifths. This would be tenths. I'm going to change to a marker. Okay. If I split my tenths in half, I'm going to have 20ths. And if I split them in another half, this is where it gets kind of tricky. Then I hope you get the idea it's going to be fourths. So that's why we usually do this mathematical way. I don't know, I don't have them the right size ratio, so I just wanted to show you how small that 40ths are going to be. So when we do it mathematically, we do times something equals something, times something equals something. What's our new denominator? What's going to be our common denominator? And that's going to be 40. 5 times what equals 40? 1, 2, 3, 4, 5, 6, 7, 8. Or you might know that it's 8. 8 on the bottom, 8 on the top. 3 times 8 is 24. 8 times what is 40? 1, 2, 3, 4, 5. Or the reverse of this, 5 on the bottom, 5 on the top. 1 times 5 is 5. Now I can add them together. So 24 plus 5 is 29 40ths. Okay, so this one was a little bit much just because our common denominator got so large, but if I had my fifths and I don't even know if I went online, if I had my fifths and I cut them to make them into 40ths, then 3/5 would equal 24 40ths. So each fifth is going to have 3/5 is going to have, each fifth is going to have 8 pieces. So if I did do this, this would convert to 8 pieces. 3, 4, 5, 6, 7, 8. Because that would be 8 for that fifth. This would be 8 for this fifth. This would be 8 for this fifth. This would be 8. And this would be 8. Okay, so I don't know if this confuses you more, but I just wanted to show you why this works, why this happens. So our answer is 29 40ths. Okay, last problem for our recorded lesson is number 5. Joe wants to make party bags for his class. He's got 426 items to put in the bags, and he wants to put 8 items in each bag. How many party bags can Joe make? All right, so let's think about this again. We'll read it again. Joe wants to make party bags for his class. He's got 426 items. I think it always helps to write it down. Items means think about what you're doing. You're making a party bag. So what would you put in a party bag? Maybe you'd put paper airplane, maybe you'd put a crazy straw, maybe you would put a couple pieces of candy. He's got 426 items. So maybe he has 426 pieces of candy, maybe he has 426 silly straws. So he wants to know how many bags he can make if he wants to put 8 in each item. So these are all of his items. So he's going to put 1, 2, 3, 4, 5, 6, 7, 8 in this bag. He's going to put 8 in this bag. He's going to put 8 in this bag. And we need to know how many 8s fit into that. So that would be a division problem. So we're going to do 426 divided by 8. Hopefully I have some room here. I don't on this one. I'll have to go on to this one. All right. 426 items divided by 8 items. So he's going to put 8 items in each bag. Let's try the big 7 way first. Okay. Will 800 fit in there? No. So we're going to have to go to our 10. So how many 10s? Let's try... let's try 30. So 8 times 3 is 24. So that would be 240. Subtract this, make this a 12. 8, 1. Okay, so 30 more is not going to fit. We have 186. So we could maybe, let's try 20 more. So 2 times 8 is 16. 160, 26. Well, any more? Can we divide 26 by any more in 8? Well, 8 times 3 is 24. So it looks like we'll have a remainder, and our total answer here is 53. So 53, remainder 2. So how many bags will he be able to make? Will he be able to make 53 bags? 54 bags? It would just be 53, and he would have a leftover of 2 items. Now, if you wanted to do it the other way, we've got 426 divided by 8. Divide, multiply, subtract, bring down. 8, 16, 24, 32, 40. All right, so 8 will not fit into 4. I'm dividing first. How many times will 8 go into 42? Well, 40 is our number that's closest. 1, 2, 3, 4, 5. Then we multiply. 5 times 8 is 40. Then we subtract. Then we bring down the 6. 8 will go into 26 3 times. 3 times 8 is 24. Then we're going to subtract. And we have our same answer. Whichever way you want to do it, I like to show it both ways because people are doing it different ways. So he can make 53 bags for his guess. And each bag will have 8 items in it, and that will take care of all of his 426, and he would even have 2 left over for himself or his sister. All right? Thank you so much, and we will see you later on this afternoon.